welcome to our channel Where to Know. So in this video we will see how to interface the photoresistor to Arduino R4 Wi-Fi board. So photoresistor, as we know, is basically a we can basically say it as a light detector, right? So whenever there is a light that is present, the resistance goes very low, and then when you see that the resistor is in the dark, the resistance of that particular photoresistor goes very high. Okay, so based on that, if you form a voltage divider network, you can actually have the value that can be read from this voltage divider and fed to a board like Arduino or for Wi-Fi. Okay, so now here you see this is a photoresistor. Okay, and then you have 10k resistor on this particular blackboard that you see, and the middle pin, which is one end of the 10k resistor, is connected to ground, and to one end of this particular photoresistor we are giving 5 volts. Okay, that means the 5 volts is going here to this pin, and the second end of this photoresistor is connected to a 10k ohms, and the other end of the 10k ohms is connected to ground. So the middle part, the voltage divider part, is the yes output of this particular board, which is light blue pin here, which is actually analog output, because based on the light variation the voltage varies, right? So we give it to a analog pin. So that means the Arduino R4 has to read the analog output of this particular section. And to just have a visual indication, what we did is we connected a LED here through a 1k resistor to pin 9 of Arduino R4 Wi-Fi board. And once you see that we have darkness, the voltage here goes down, and we keep a specific threshold, and once the voltage goes below a threshold, we'll try to light an LED. Okay, if the brightness is high, the LED will be off. Okay, and the same indication will be thrown out as a message on the I2C based LED. This is a 16 cross 2 alphanumeric LCD, which has SD and SCL pins, and we already have a video on this in our channel. This we are connecting to the I2C pins of the Arduino or for Wi-Fi. So the important point here is all these sensors can work on 5 volts. So you don't need any additional voltage translation or anything. A very simple circuit, right? So now let us look at how the code works. So to start with the code, basically we need two libraries, wire and liquid crystal I2C, and we have shown in the previous video how to install these libraries by going here and searching for your library. Okay, and here we are creating an object, liquid crystal I2C. And basically this is a method where we are actually trying to give the parameters, and we have two pins which are declared here, the definitions, pin definitions, LDR and LED pin. Okay, so the A0 is defined as LDR underscore pin, and pin 9 is defined as LED underscore pin. So we can use LDR pin and LED pin in the further code. Okay, and then there is a threshold that is set. So whenever you read the analog value, whatever the register value that gets converted by the ADC, that value after regular testing, it is set as a threshold, and we have put as 775. Like for example, you see here there is a scrolling that is happening where you have 900 value under a full light condition, and see now we are actually blocking the sensor, okay, for light, and you can see the value is getting reduced, right? It has gone to 689 and all. So we have put a threshold. Whenever the condition the n value, ADC value, goes below 775, it is considered as a dark condition. So we have used a pin where the LED pin is set as output, and then there is a serial port. This is the serial monitor that you are seeing, which is working at 9600, and initially we are trying to print street light system started reading LDR values. So basically why we are saying street light system is we are trying to emulate a street light scenario where based on the light that is present, we are actually controlling the LED. Okay, and then LED is initialized, LCD is initialized, LCD backlight is turned on, and we are setting the cursor at 00, and we are printing it initially, and after a delay of 1.5 seconds, we are clearing, and then we are entering a loop here. Here you can see we are trying to read the analog value from this particular pin using analog read and passing to a variable, and we are actually trying to print the same value here. So whatever analog read is done, okay, the digital value, the register value is printed here. Okay, and the same thing we are actually printing on the LCD as well. And so here if you see, we are deciding the light condition. So if the LDR value that is read is less than the threshold value, we are actually turning on the LED. Okay, and we are actually printing. The condition is dark and LED is on. That means you detected darkness and the LED is turned on. And then you can see the other scenario where if the LDR value is greater than threshold, that means there is a full light condition, the LED's pin is pulled low, and we are actually printing as LED off, and there is a light condition. Okay, and after every 0.5 seconds we are actually repeating the loop. So this is how the entire code works. So basically we are using the Arduino IDE here, and this is easy to use, and you can actually generate this code using tools like ChatGPT, assistants like ChatGPT. You can actually give your prompts and generate code as you require. Okay, for simpler things you can use, and then any applications, any parameters that you need to change, you can actually change those parameters and then use the code accordingly. Okay, so this is how the code works. Hope we gave a glimpse of how the photo resistor sensor can be interfaced to Arduino R4 Wi-Fi board. Thank you. So here is the connectivity on the actual board. So this is the Arduino R4 Wi-Fi, and we can see here this is the sensor. So the photoresistor is here, and we have 3 pins. The red pin is the power pin, which is going to the 5 volts. The yellow pin, which is actually the analog output, is connected to the A0 pin as we see here, and these 2 pins, if you see the other yellow and the blue wires, are actually connected to the I2C LED. Okay, and this is the normal condition where there is a full light, you can see here, and this is the LED which is off. So if you see the display, okay, we can clearly see that it says LDR 978 as displayed on the serial port, and light is off. Now we'll cover the sensor. Okay, see the LED is on, and you can see here darkness, LED on. Now let us remove. You can see here again LED is turned off. Okay, and the display also says LED off. Let us again try to do this. See, LED is on, LED is off. So this is how the whole board works.